Today we'll solve another problem from array category called move zeros. And as always, we will start with our problem statement, input output, and then move to a concrete example, and then finally code out the solution. So in this case, we have a pretty straightforward problem statement. We only have one input, which is an integer array called nums, and the return type is void, so we don't really return anything. The only thing that we have to do is move all zeros to the end of the array while moving the non-zero elements to the front and keeping their relative order. The tricky part of this problem is that we have to do it in place, which basically means that we cannot copy to another data structure. We cannot create any helper data structures to use in our solution, which basically means that we will have a constant space complexity. For the examples, as you can see, nothing special. I will start with the second example. It's pretty uninteresting. It's only one element and it's zero. So the input is basically left untouched and there's nothing to do. It's just a zero. The first example is more interesting. And as you can see, we have 1, 3, and 12, which are non-zero elements that are moved in front, while the two zeros are moved to the back. As for the constraints, nothing wild, nothing special. The nums values are in a range of the integer, max integer, while the length of the array is from 1 to 10 to the 4. So in that case, we will hope to find an algorithm that performs in a linear fashion because of the size of an array. And we will now move to the concrete example. And here I have the same example from the problem statement. And usually how we solve this problem is that because we have to do it in place, we will have one iterator that will basically just traverse through the array, and we'll call it iter. And we will position it the first element, and the second pointer we will call writer. Now, iter will be just basically an I variable inside the for loop. It will just go from 0 to the array length -1, while the writer will only move if the element that the iter is pointing to fulfills some requirement. For example, in this case, we want to place the non-zero elements to the front, which basically means if the iter is pointing to a non-zero element, we can write that element to the position where writer is pointing to and move writer to the next position. So in this case, we will initialize the writer to 0 as well. So writer will point to here, and we will have the writer pointing to the first element as well. The thing that you have to note is this is the same array. This is just for the explanation purposes. So the first element is 0. So the writer, we don't move the writer. We just move the iterator to point to the next element, which is a non-zero element. And so we can write it to the position where writer is pointing to. In this case, it's pointing to the first position. So we just write it here, and we move the writer to the second position. So this will become 1, and this will become 1. And then we move the iter to the next. As you remember, it's just a for loop. We move it to the next element, which is 0 again. So nothing interesting is happening. We move it to we don't move our writer. We just move the iterator to the next element, which is 3. So we can write it to the position where the writer is pointing to. In this case, the second position. So we just copy it over, and we can move also our writer to the next position. So we do the same for the 12 because iterator is now pointing to the last number, and our writer is now pointing to this element. But we are at the end of our array. The iter is pointing to the last element of the array. And to finish up the solution, we just have to copy all the zeros that we had. And that basically means just fill the rest of the array with zeros. And that's basically it. In this case, we will have all the non-zero elements in the front, and they will also keep their relative order. Let's move to the coding part. First, we will initialize our writer pointer. We'll initialize it so it can point to the first location, first element of the array. Now to represent our iter from the example that we showed, we will just use the plain for loop, and the I that's declared inside the for loop statement will represent our iterator, which will basically just iterate over all the elements of the array. Next, we will check if the current element that iterator is pointing to is not 0. In that case, it fulfills the requirement to be written at the position where the writer is currently pointing to. So we basically just do that. We take the current element the iterator is pointing to, and we just place it to the position where the writer is pointing to. And we finally increment the writer to move it to the next cell so we can prepare for the next non-zero element. After we reach the end of the loop, we just have to fill the rest of the array with zeros. We do that by incrementing the writer all the way to the end of the array, and each time placing the 0. The space complexity is constant because we are doing all in place. All operations are done in place, while for time complexity, we just basically have simple for loops that traverse the whole array, and that means that the time complexity is linear.